The next speaker on this, before we have the actual roundtable, will be Giovanni Romano, one of the members of the Light4Lungs. Giovanni from Florence, in addition of being one of the intellectual fathers of the idea Light4Lungs, has also spent a lot of time in his professional life developing innovative light sources for different kinds of phototherapies. And today I am asking him to present not the Light4Lungs again, but Light4Lungs in the context of innovations in lighting procedures for health. Giovanni, please, thank you.
Thank you very much. Thank you for your very kind presentation. So I would like to spend a few minutes to probably, starting from the Light4Lungs project, proposing ideas which share with Light4Lungs many components, like the fact that they are ideas related to phototherapies. They are, as much as possible, non-invasive and possibly innovative. So these are just examples. I know them better than others, because together with the University of Florence and a startup that I contributed to found in Florence, Probiomedica, we have developed. And I will just very briefly present these ideas and end with questions, because I end up always with more questions than I had at the beginning, but I think this is very good, especially for the next session. So I titled this innovation as a general subject. And the first question that I would like to share with you is what makes a light source innovative. So this aspect was also, of course, discussed when related to the preparation of the project of the Light4Lungs. And you may think that innovation can be in many respects, like my source is innovative because, for instance, it is an aerosolized source and not a solid source. So this makes it innovative. Possibly, maybe that is an innovative aspect, sure, especially if it is good to, for instance, treat difficult districts. Another reason for innovation could be the dimensions. So I have a single cell biological laser that was a work of more than 10 years ago. Yeah, that is innovative. That is tiny source or a very big source. That could be, or even the working principle, like my new source is randomly chosen phosphorescence based, like for instance the Light4Lungs, or with a nonlinear phenomena or inorganic or bio-derived. So these are reasons for innovation. Another reason could be that as a medical physicist I may understand well that the new source answers an unmet need by the clinician. For instance, to reach a difficult district, which was the case with Light4Lungs, so the lungs is not easy to reach with a light source, or decrease the invasiveness, which is associated to patient compliance, or for instance, to increase the technical characteristics of the source. So probably all of them are reasons for innovation. The last one is the one I like best, because in the medical physics field, which was in the service of the project, I think that to answer to an unmet need is the most important thing. So that our goal is there. We, of course, did not arrive up to the human being. That was not in the project. Still, we have to design the project with that vision, which is very important, okay? So in the following, I will very briefly, skipping some slides, describe different sources which are not Light4Lungs, but which again share many components with Light4Lungs. And out of this very brief presentation, I will end with some questions. So the first source is an ingestible light source. This idea came many years ago, together with the gastroenterology group in the University of Florence. So why an ingestible source? The problem is infection by Helicobacter pylori. which has a worldwide prevalence, and of course, I would say unfortunately, but it is, of course, it is characterized by an increasing rate of antibiotic resistance. So light could overcome AMR? We think yes. We know from the literature that pylori is photosensible, okay? And in time, for instance, the source you see there, different sources have been designed to illuminate the stomach. For instance, there you see an inflatable balloon which emits violet light. So it works, yes, it does not eradicate, but it works. It is invasive, okay, and uses one color only. So that was a fantastic work, but it was in 2009. So the idea was to have no more limitations due to the presence of a tether, which can be the gastroscope, which can be an optical fiber, linking the balloon inside with a source of light which is outside of the body. That is clear. In that case, that was a powerful light source out of the body. Okay, so you need a tether. You don't want that because you prefer to have something which is less invasive. So that's the idea of a swallowable luminous device. And then the slogan, the motto could be just take a pill of light. Okay, this is the idea, and then we prototyped it in different ways with 2 patents. These are the new ones, adding colors from the research because we have interest in using different colors. The idea is a bit the same as this morning. So action spectrum, in this case, it's more complex. It has different peaks, so different colors all in the same moment. I don't have the time to explain why, but you can imagine that here is a bit different as the bacterium is hidden inside the pleat of the stomach. So you have to pass the stomach tissue, the gastric mucosa tissue before arriving there. Okay. So you have very simple components, and this is to say, probably in our vision, innovation is not necessarily linked to very complex things. In principle, an aerosol is very simple in principle, but then it was hard work to attain that. Finally, we ended up with an animal model, and I will discuss a bit without, I will have a question about this. So I want to cite this animal model because we wanted to acquire data about the biocompatibility, so the safety. That was not for efficacy, just for safety. So the animal was safely administered the pill. They will chew it, so it is anesthetized. Otherwise, the animal will chew the pill, and that's not what we want, okay? But anyway, the pill was safely expelled by the animal. The second light source I would like to show you is similar, but it is an endoscopic light source for the same purpose. I want to show it on purpose because it may seem that it is a step back respect to what I have presented to you before, because here you have the tether. The difference between what I presented to you in 2009 is that here we have a different source and different colors, and we believe that it is more effective, but still we have to demonstrate the efficacy. So when you inject light into an optical fiber, you can have fibers which have diffusing tips so that they are inserted in the stomach and illuminate with a broad geometry, which is what you want to reach as much surface as possible. So to make a long story short, this is the prototype. The project has ended 2 months ago, and on the left-hand side you see the prototype. So the boxes contain the sources. There's a chiller, so a lot of power means also a lot of Joule effect, a lot of, let's say, energy lost in heat. But anyway, you see the fibers exiting the box, and on the other side, you see an ex vivo pig stomach being illuminated. There's a novelty I didn't tell you, which is that we use the optical fibers not directly in the stomach. So how did we go into the stomach? The idea is to use a gastroscope. We will see in a moment why. A gastroscope is a diagnostic device, right? So if you couple it with our device, and our device is the source outside the body plus the fiber, that's our device. If we couple them, how? We can insert the fiber into one of the channels of the gastroscope. Okay, it has many channels to do different things. I exploit one of them, I insert the fiber, I couple them, and I define a therapeutic device. Why this? let's keep it and answer in a moment. Third and last source, an UVC source for environmental disinfection. So UV can be used as an antibacterial, antiviral source. It's not a photodynamic effect. It damages the genetic material, okay, and possibly also the protein component in virus. So the idea is that you don't see UV, but UV acts against environmental agents, pathogens, which can be in air. So typically what we envisaged is to have light curtains in between people. And while a virus is passing from one to another, it is illuminated and hopefully inactivated, okay? So this idea can be made more complex by a flux of air, so you force the particle to follow the light as much as possible, but these are, let's say, details. We are in this phase, so we have demonstrated that if you have infected mouse and they breathe out the virus, so the healthy mice remain healthy because in the middle we have our source. So this is what should happen with people, what we hope will happen. So we have patented it and we are working on further studies to go as far as possible towards the human being. So let us conclude with questions, as I promised. So let us start by the first source. This is our motto, so just take a pill of light. So in the light of this idea, and of course not only us, there are many ideas starting from the Light4Lungs, using light as a therapeutic, let's call it principle possibly, so photons don't have a mass. So maybe principle could be the right word. So a question is starting to arise in the scientific community, and the question is, should we reconsider the definition of drug? Could we define a photon a drug? What about photons? So, you know, they share many things in common, like I deliver a drug, I deliver photons, okay? It's a physical principle, it's energy flowing, there you have a chemical component. That's an idea, that's a question. About UVC, so you have your UVC source. The first question, that's in a different respect. To be used in the case of pandemic only, when we proposed, asked for money for a patent, they told us, okay, we'll grant you some money, but that will be used only if another pandemic will arise. And what? So it was not our idea. So our idea was to use it in everyday life. And I, as a second point, I propose a different way to see the same thing. So not environmental disinfection, but it is also an UVC source to avoid spreading of airborne infections. Think of an invisible barrier put in between seats in trains, cinemas, offices, whatever you can think. So you disinfect and you prevent spread of infection while you are there. So you don't need to have costly procedures while no one is there during the night, and then you come there. Last point, I didn't include it, but that's important. UV is known to be damaging our tissues. It's true in many respects. What about UVC? So the wavelength in this case is 222 nanometers. This wavelength is short enough that the penetration in the tissue, like the skin and the eye, okay, skin is a few microns, so basically it does not pass the dead layer. So it could be, and actually there are proofs of it, much safer than the other UV sources, okay? That's a paradigm, and that's difficult to change the idea that all UV is dangerous. So this is another point. Last, while not the pill, why we had the other, let's say, invention, because we are patenting it. So the point here is different, and it may become a question. Patient compliance is important. That's why we thought about the pill. You want to take a pill, you don't want to have a gastroscopy with a fiber inserted in the gastroscope and stay there for 20 minutes. Okay, but also the clinician compliance is important. And by clinician compliance, I mean that when we propose the pill, they are saying like, maybe I don't know this technique, I am a bit scared, is it safe, and so on. While if you propose them, use your gastroscope in a slightly different manner, everything remains the same, and the clinician is much happier. So maybe the patient is not, but if the clinician is happy, then it is a technique which has chances to be diffused. So there are these 2 points that we discovered late. And the last is related to an animal. We're thinking about how to transpose from tech to market, and market means I have to make many trials on animals and people. So procedures, in our experience, can be complex, can be long, and they are expensive, and there is a lot of bureaucracy. So to which extent the governance of animal trials is uniform at the European level, what Europe is doing, I'm sure they are thinking of this, but this is an important point, because sometimes you lose months in having permissions, which is, I mean, it's very fine, I have to have permissions, but not in a year, while during that year my project is over. Thank you very much.